All right, we're going to move on to number 5. All right, so this question is, what value should be assigned to k to make f a continuous function? So when I study number 5, I'm looking at this, I'm going, if this is going to be a continuous function, they must be assuming that there's a point discontinuity. There must be a hole here somewhere, and that hole must be occurring at x equals 3. So we really need to know what the limit of this function is at x equals 3 or as x approaches 3. So if we know what the limit is, then we can let k be that value. So let's see how we can use the 3-part continuity test to help us find this. All right, so the first part is this. We want it to be continuous. The interesting place is 3. So do we have a functional value? Yeah, we do. F of 3 is equal to k. And the second part of the 3-part continuity test says, is the left limit equal to the right limit? Well, let's study this situation. It's a little bit different. Okay, notice that this piece right here is defined for all x's except 3. So actually my left limit and my right limit, okay, are going to be involving this piece only. I mean, as I approach 3 from the left and 3 from the right, I'm on this piece both times. So I'm just going to find the limit as x approaches 3 of that piece. I don't have to worry about from the left and the right because it's the same piece. All right, and as I copy this down here for part 2, I'm going to go ahead and factor the numerator. Okay, and remember, we're going to use the denominator to help us factor the numerator because really what we want to do is cancel the x minus 3. So I'm assuming that I can factor the numerator into one binomial that has x minus 3. The other one's going to have to be x plus 5. All right, we're going to cancel or reduce this common factor down to a 1. So what that means is we have a point discontinuity occurring at x equals 3, at the x value of x equals 3. All right, but to finish this limit question, let's plug in 3 where we see x. I'm ready to plug in now, and I get 8. All right, so for part 3, yikes. Okay, f of 3 must equal the limit as x approaches 3. And I'm just going to put f of x here. Sorry, things keep disappearing. Okay, so then I'm going to come back up here. I'm still in part 3 because I'm just running out of paper here. F of 3 is k. And the limit of the function as x approaches 3 is 8, so we're done. K equals 8. Now I'm going back and making sure I read the question. Did I answer the question? Yeah, I did. I found the value of k to make f a continuous function. Okay, so there's several all grouped right here together, even on the back, that are similar to this. Just use the 3-part continuity test. Okay, let's turn over. I want to do something on the back as well. It looks like 7 and 8. Actually, 7 doesn't even look like a different problem at all. 7 looks actually like number 5, so I'm not going to waste your time. So let's move on to 8. All right, let's consider this piecewise function. Which of the following is true? Does the limit as x of 3 does not exist? Okay, let's explore that that question. As I approach 3 from the left and the right, I'm always on the same piece. Okay, so I guess I'll go over here and show that work. I don't need a left and right hand limit. Oh, goodness. As a matter of fact, I'm going to go ahead and factor the numerator as I'm rewriting it. Notice that we share a common factor. So when we reduce and divide out this factor, okay, we're going to have a hole at x equals 3. Okay. Well, let's plug 3 in, and our limit does exist, and it is 6. So let's go back to the question. Consider the following given function. Which of the following is true? Yeah, that's true. Is f continuous at x equals 3? It's only continuous if the limit equals the functional value. So consider this part 2 of the 3-part continuity test. Part 1 would be, is the function defined at 3? It certainly is. And it's 6. And because these two are equal, we can say yes, it is continuous. Because that is the 3rd part. Okay, and this was an equal sign right there. All right, and 3 says, is the line x equal 3 a vertical asymptote? No, I think we've already established the fact that when we reduce these common factors, divide out of 1, that x equals 3 is not a vertical asymptote. As a matter of fact, we have a point discontinuity at x equals 3, so this is not true. So coming up here, we're going to say that 1 and 2 are true. Okay, all right, and just glancing at some of these others, let's look at 9. All right, so notice this piecewise function has 4 pieces, and it's asking us for what values of x is f not continuous. Well, again, if you study all 4 of these pieces, they're all well behaved. They're all continuous on their domains, so we really only want to consider the breaks. Now, what x values do we switch over from being one function to another? And you can see there's 3 breaks. There's a break at x equals 3, there's a break at x equals 1, and there's a break at x equals 2. So actually for this problem and all this working space, you're going to need to do the 3-part continuity test on x equals 0, x equals 1, and x equals 2. All right, let's take a look at 11 and 12. All right, so we have another question about which of the following is true about the function f given below. Okay, for this particular problem, you might be thinking, do I need a calculator? Do I not? Well, you probably, it'd be nice to have one, but there's not necessary to have a calculator to answer this question. All right, we have some background information that we can use to help us answer this. Is f continuous at x equals 1? Well, to determine that answer, you might want to factor the denominator. Okay, so set the denominator equal to 0. Let's factor it. And if x equals 1 gives us a 0 in the denominator, it's not continuous. I don't know what kind of discontinuity is there. Jump, vertical asymptote, point. All I know is it's not continuous, so let's factor. So it must be 2x and x here. And then I'm going to have to multiply 2 negatives to get a positive, so it's just a matter of placing them in here. I'm going to do -3 here and -1 here. Because I know that factor will give me a 0 of x equals 1, or actually give me a solution of x equals 1, and that's what the question's about. Okay, so I factored. And I noticed that when I solve each of these for 0, for this one right here, when I move the 3 over, divide by 2, x equals 3/2 would make the denominator 0, and x equals 1 makes the denominator 0. So f is not continuous at x equals 1. That's false. This is false. Okay, if you study it a little bit further, notice that we have quantity x minus 1 squared on top. So I can divide out an x minus 1 here, and it leaves 1 in the numerator. And so that's actually going to be a point discontinuity. So does f have a vertical asymptote at x equals 1? No. That's false. It has a point discontinuity. Now, had I had the exponent of 2 down here and just a 1 exponent up here, I would have completely canceled the x minus 1 from the top, leaving one of the factors in the denominator. Then that would have been a vertical asymptote if I have more in the denominator than I have in the numerator. Okay, and this question is talking about end behavior. All right, so is there a horizontal asymptote at y equals 1/2? Well, that must mean that my powers of my numerator and denominator are the same, and I'm looking at the coefficients. Okay, or you can capture the model if we use calculus notation. I can either go to positive infinity or negative infinity for end behavior. All right, so capturing the model, if I were to expand that, I'd have x squared on top as the leading term over 2x squared. Okay, as a review, we simplified. Okay, and that did leave us 1/2. Whether I'm approaching positive infinity or negative infinity doesn't matter. My answer is going to be 1/2. So that's a true statement. My intention wasn't to do this whole thing with you, but I think I'm kind of glad that we did because there was a lot involved in here. All right, so number 3 is the only true one. All right, and at this point, I might just encourage you to pick up your calculator and just confirm that when you type this into Y1 and you graph it, that what we did here was correct. Okay, so for number 12, which of the following is true about the function given below? Okay, what I want to say about this function is this. You might want to kind of memorize it. They tend to seem to like this kind of graph right here and asking questions about it. So sine x over x, this graph has a point discontinuity at x equals 0. And this was the graph that actually crosses its horizontal asymptote an infinite number of times the further you go out. Okay, so this would just be one that I would try and memorize. And I think that you can answer this question successfully based on this graph right here. So hopefully this will be enough information in the 2 videos to give you some confidence and some reminders about the topic of continuity so that you can successfully complete the other problems. Okay, these were certainly enough notes for one night, so what we'll do is we'll complete the remaining problems in class the next time we meet.